So we'll start a new chapter today. So the name of the chapter is, it's a very interesting topic, one of my favorites, laws of motion. So laws of motion, and these laws were developed by a scientist called Newton. So these are called Newton's law of motion. So Newton's law of motion. Okay, so we'll study about these. So I think this is chapter 5 in your book. Let me confirm it. Yeah, laws of motion. This is the chapter 5 in your physics textbook. Okay, so laws of motion. Laws of motion. Okay, so now before we directly move on to what are the laws of motion and all those things, so we'll have to understand what are the factors that may influence the laws of motion. Okay, so now the first and the most important and only factor that affects is inertia. So we need to understand what inertia is before moving into the laws of motion. So inertia is a tendency that is present in a body whenever it is in the state of rest or in the state of motion. Doesn't matter. Okay, so body can be in any state. It can be moving or it can be in the state of rest, right? And inertia will be present in both of the states. Now what is basically inertia? Inertia is tendency of a body to resist change, right? So it is a tendency of a body to resist change. So if a body is in the state of rest, will want to remain in the state of rest, right? It doesn't want any interference when it is in the state of rest. Or when a body is in the state of motion, a body would want to stay in the state of motion, and it do not want anything to change. Like for example, if I say, it's a very common example, you are traveling in a car, right? Sitting inside a car, and as like I've taught you already about relative velocity, right? How we calculate the velocity. Velocity is a relative quantity, and we don't have an absolute value of velocity. So the velocity of a moving car can be 40 km per hour for a guy sitting outside the car, and it can be 0 for a person sitting inside the car, right? The same car may have two different velocities. That's why we have velocity to be a relative quantity. It is expressed in relation to something else, right? Now if you're sitting in a car straight like this, and the car is moving at, like, let's say 40 kilometers per hour. Now since the car is moving, you are inside the car and you're moving with the car, so your velocity is obviously the 0 with respect to car. You are not moving with respect to car because the car is moving with you. So your velocity with respect to the car's velocity is 0. So you are moving same in the same direction with the car in the same speed. So you are basically in the state of rest, right? Practically, if you think about it, you are in the state of rest. Now suddenly there's a turn, there's a right turn. So the car is supposed to turn right. So when the car turns right, you'll notice that your body will tend to move towards the left side. Have you noticed that? So when a car is giving a right turn, your body will start moving towards the left hand side, right? Why is that happening? Because your body is in the state of rest, right? And the car is giving a right turn. So which basically means the body is being forced to take a right turn, but the body does not want to turn. The body is trying to remain in the same position. It doesn't want to turn this way. Rather, it'll try to stay in the same state. It's trying to stay in the same state. It was straight upright like this. So when the car is turning right, your body opposes that. Body will try to turn left. So actually that is an example of inertia. So inertia is tendency of a body to resist change. So it will not try to move away from the state in which it is right now. So it doesn't want to move away from the state of rest. It will not want to move away from the state of motion. So that is known as inertia. Okay, so this is a very common example that you have encountered everyday life if you have traveled in a car. So if you wish to take a right hand turn, right? If you wish to take a right hand turn, your body will tend to move to the left to resist the right hand motion change, right? So that is known as inertia. Now since we know about inertia now, so inertia is basically nothing but it is a tendency to resist change. So you are trying to resist some change that is happening to the state you are in. So if you are in the state of motion and something is about like forcing you to stop, your body will not. Like for example, if a car is moving at 40 kilometers per hour, so a car is moving at 40 kilometers per hour, right? And suddenly the driver applies a hard brake to it. So the driver like sees some big truck coming in front of him. So he didn't notice the truck from like 2-3 seconds ago. He just saw it right in front of him. So out of panic, he just hard press the brake. So what will happen? The car which was moving at 40 kilometers per hour will come to a standstill. So what will happen to the passengers inside? The passengers were moving with respect to the car now. Suddenly the car has stopped. The passenger will continue to move, right? The passenger will move forward. They'll be pushed forward. The body will automatically go forward. The body will not want to change its state. It was moving with respect to car. The car suddenly stopped because of a sudden braking, but your body will move forward. That is the reason why we have seat belts in car, right? So to prevent those kind of things that happens inside a car. That is basically physics, right? Physics is causing that to happen, and that physical term is called as the inertia. So you should not have any doubt about inertia from today. So inertia is nothing but it is basically the tendency of a body to resist change of state. So a body in the state of rest will tend to resist any change that will that will try to change its state. So if a body is in the state of rest, if something is being applied on the body that is trying to change its state, the body will resist that change and will always stay in the state of rest. Or that same thing will be applied to the state of motion, right? So inertia is nothing but the tendency of a body to resist change. Is it clear, bhai? What is inertia?
Yes.
Okay, nice. So we move on to the next topic, and the next topic is called, now we move into the laws of motion. Okay, I'm back. So hello. Yes. So now we move on to the first law of motion. So let's try to understand the first law of motion and the third law of motion today. So we'll do the second law of motion tomorrow. So we'll actually try to understand the first law of motion. So what does first law of motion tell? So it is a direct application of inertia. Okay, so a body, so according to the statement of first law of motion, wait, something is wrong with my camera. DROID. So it is a direct application of inertia. So basically what does it tell is a body in the state of rest or motion will continue to remain in that state. Until and unless some external forces applied. So this is the first law of motion. So the first law of motion states that a body that is in the state of rest or in the state of motion. So if a body is in the state of rest, so this marker which is staying in my hand right now, can you see the marker and my hand? Yes, you can see my marker. See the marker in my hand, right? So now the marker is in my hand right now, and this marker is in the state of rest. Now, by no means, if I don't move my hand and if I don't have any external force applied on the marker, by no means will the marker move here automatically, right? The marker can only move here if and only if I apply some force on the marker. I pick it up, put it here. So now this is changing its state. It changed its state from rest. It was in motion. Now again it's in the state of rest. Now it moved. So what happens is it's basically changing its state from the state of rest to motion. So now this basically is a body in the state of rest rest will continue to remain in that state. The body will continue to remain in the state of rest unless something external is applied, unless I incline my hand like this, right? Only when I incline my hand like this, the marker starts rolling, right? If I keep my hand still, if my hand is not moving, it is perfectly still, then the body will completely remain in the state of rest. There will be no point of this body moving, right? Unless an earthquake comes and shakes it. So earthquake is also something external, right? So a body in the state of rest or in the state of motion will continue to remain in that state unless you apply something external. So for the motion example, we can think about the car example again. So you have not applied the seat belt. You have not put this, you don't have the seat belt on, right? So you are moving. Suddenly your driver suddenly applies the brake, right? Hard brake. What happens? You tend to move continuously in the direction of the car. So your body doesn't stop until and unless the brake is applied, right? So unless the brake is applied, your body will continue to move. So since the brake is applied, that brake is external, that will cause the change of state. So you were moving, you were in the state of motion. Now suddenly after the brake is being applied, you just move forward and then you come to a state of rest, right? You go forward, then you just move back. Now you are in the state of rest. The car has stopped. So now this basically is a body in the state of rest or in the state of motion, right? A body can be in the state of rest or in the state of motion, will continue to remain in that state unless an external force is applied. So now you may think this sounds a little bit crazy. Why? Because a body, like for example, if I push a pen in the table, right? If I push a pen in a table, like I just push the pen, why does it stop then? I have like no force is being applied. I just applied a force for 5 seconds. It just moved there. Now why is it stopping? So I have not applied any braking force to it, right? I have not applied any force that is resisting the motion. So why is it stopping? So now the best answer for this is the surface always applies a force resisting the motion, right? Smoother the surface, the longer the body will roll, right? So if you have a pitched carpeted road, like if a metal road, right, the car will move faster, right? The car will move faster. If you have rough road, your car has to move slower, else your car will break down in between, right? So if I give you an example about a tabletop, right? There is a tabletop like this, and according to this statement, a body will remain in the state of rest or in the state of motion unless an external force is applied. So if I have a cylindrical body and I apply a force here, it will start rolling for some distance and then it comes to a state of rest. Why is it coming in the state of rest? Because I just applied a force here, right? Why it should not be stopping, because according to this law, a body in the state of motion will always remain in the state of motion unless I apply a force that will go against the motion, right? Only if I put my hand in front of the cylindrical thing that is rolling, only then will it stop. But here I'm not doing anything like that. I'm just applying a force this way, but still it is stopping. Why is this happening? This is because this surface of the table is not completely smooth, right? This surface of the table will apply a force that will be against the motion of the body, and that force is known as the force of friction, force of F-R-I-C-T-I-O-N. So force of friction, F-R-I-C-T-I-O-N, okay? So F-R-I-C-T-I-O-N. So force of friction is the force that is applied against the motion of a body, right? And that will be applied by the surface in which the body is moving. Like for example, air also applies some friction. So when you throw a paper plane, if you make a paper plane and throw it outside, as per this law, a body in the state of motion will remain in the state of motion. So if you throw a paper plane outside, the paper plane should continue to move. It should never come down. It should never ever come down, right? Because if you throw it straight in the straight direction, like straight above your head, right, the plane should always stay in that height and it should always move forward, because a body in the state of motion will always remain in the state of motion. It will not come to the state of rest unless you apply something external to it, right? So why does the plane fall down after some time? That is because there is friction that air applies on the plane. So because of the air friction, the direction of the airflow being opposite to that of the flying paper plane, the paper plane will gradually decrease, it will descend and ultimately plummet, right? That is because there is something external, right? If you don't want anything external, that is space, that is vacuum. Vacuum is a place where there is no air friction, right? There is no air inside vacuum, so there is no air pressure or there is no air friction. So there is nothing that can resist the motion of a body in space. So a body, if you throw a body in space or vacuum where there is no gravity, let's say, that body will keep on moving at the same velocity. It will not decrease its velocity. The velocity of a body traveling in a frictionless environment. If the environment is completely frictionless, there is no friction, there is no force that will oppose the motion of the body, then the body will continuously remain in that state. So if you just push it at a velocity of 2 meters per second, after 10 years, if you locate that body will be continuously moving at the 2 meters per second. It will not increase, it will not decrease, right? Unless if there is some external force that is being acted on the body. Clear? So friction is the force that will be against the motion of the body, and that will be applied by the body or the surface in which the body is moving. So if you are rolling a tube on a tabletop, the tabletop will apply a force of friction that will oppose the motion of the cylindrical tube. So that is friction. So this law is completely applicable and completely true, but it is not applicable. There is no direct application in Earth, right? If you just think about it, if you just logically think without understanding friction, if I had not explained you about friction, then this law would sound very stupid to you, right? Because simple, if you like push a pen in the table, that pen will obviously come to a stop after some time, right? But this law like clearly tells the body in the state of motion will remain in the state of motion unless you apply some opposing force. So if only if you know what friction is, you can justify this statement. You can find this statement justifiable. Okay, so a body in the state of rest or in the state of motion will continue to remain in that state unless some external force is being applied on the body. So this is the first law. Now we go to the third law. Third law is very, very simple, very interesting. That is, every action has an equal and opposite reaction. Equal and opposite reaction, which means anything you do, opposing force which will be equal will always act. Like for example, if you have a pistol in your hand, right? If you have a pistol in your hand and you fire a shot from the pistol, so the pistol will not be stationary. When you fire the shot, that pistol will move back as well. In physical aspect, it is called recoil, right? This is the direct application of Newton's third law of motion. So every action has an equal and opposite reaction. So what is the action when you shoot a bullet? So the action is the bullet moving forward. So bullet is moving forward. So what will be your reaction? Reaction will be opposite and equal. So it will move back. So the bullet will move front, your gun will move back. So that is Newton's third law of motion. And the force at which the bullet is moving forward will be equal to the force at which the gun will move backward. But since the bullet is very small, the velocity will be more. So it will travel faster. Since the gun is heavier than the bullet and it is held by your hand, it will just come back and it will not be that harmful to your body. But if you stay in front of the bullet will go inside your body and damage the tissues or organs, right? So every action has an equal and opposite reaction. There's another example for this, rockets and launching of rockets. So how do you think rockets, when they apply force downwards, how does it go upward, right? So for a rocket, if you have seen the launch of rockets, so I'll check whether if I can find a Google image for that. Okay, one second. Yeah, I got a minute. One sec. Open folder. Okay, now we have a rocket launcher. So how do you think this rocket moves upwards? This is because a direct application of Newton's third law of motion. Every action has an equal and opposite reaction. So what is the action here? The action here is the engine firing downwards. So the engine is firing downwards. So engine is facing downwards. The rocket has to move upwards. So the engine is firing downwards. So all of the engine, the combustion, the burning that is happening in the engine is directed downwards to the ground, right? So because of that force that is being applied to the ground, an equal and opposite force will act directly upwards. So that downward force of the engine's burning will cause the rocket to move up. So that is a direct application of Newton's third law. Every action has an equal and opposite reaction. So this reaction will be equal. This upward movement will be equal to this one, to the downward movement of the downward combustion of the engine, and the upward motion of the rocket will be equal, but will be opposite. So the downward motion, the motion of the engine force will be acting downwards. One second la. Where was I? I was like explaining the third law, right? So third law like there is an action, there is a reaction, but the action and the reaction are opposite, but they are also equal. So there is an action from this engine that is downwards. Yes, the force is applied downwards. There is a reaction, that is the rocket moves upwards. So this is the action. This is the reaction. So every action, okay. So you don't need to think about only things where upward motion or downward motion or straight motion by car engine, whatever it is. You don't need to think about all those things only. So you don't need to confine yourself to this. Every action, you might not like understand how it works right now, but every action has an equal and opposite reaction. Like you apply force to open a door, right? You apply a force. The door will also apply a force opposite to you, opposite to your force. That's why you need to apply, like if you have a big door and something is placed behind the door, you need to apply more force, because the door will be subjecting more reaction on your force. So you may not find it like applicable everywhere, but every action. So statement tells you that every action, right? So every motion. So me just scribbling using this pen on this pad right now will also be affected by this law. So me writing on the pad, right, every action. So this every action, when I wrote this these two words, there is a reaction force that will be exerted on my moving hand, right? So that is the Newton's third law of motion. It is applicable everywhere. Okay, and it is valid and it is completely true. Okay, so this is the third law. First law body in the state of rest or in the state of motion will remain in that state unless and until some external force is applied on the body. Okay, so now I want you to ask me some question if you have any doubts.